Hello and welcome back to another video. In this problem, we're asked to prove using definition 6 that the limit as x approaches negative 3 of 1 over x plus 3 to the fourth is equal to infinity. So the definition 6 states that the limit as x approaches a of f of x is equal to infinity, right? This means that for every positive value m, there is a positive delta such that if 0 is less than the absolute value of x minus a is less than delta, then f of x is greater than m. So the first thing we need to do is state what are the actual values that we're plugging in here. We have 0 is less than the absolute value of x minus a is the value that x is approaching. So x minus negative 3 is x plus 3. It's less than delta. F of x is 1 over x plus 3 to the fourth, and this is greater than m. And we basically need to say that for every m we pick, we can relate it to delta. So the first thing we need to do is we need to get rid of this. If we're saying that the absolute value of x plus 3 is greater than 0, this is the same as saying the absolute value, or saying that x plus 3 is not equal to 0, and therefore the x is not equal to negative 3. So we can eliminate this because we're looking at the limit as x approaches negative 3. We don't care what's happening at negative 3. So we can simply say that the absolute value of x plus 3 is less than delta. Here we can say if 1 over x plus 3 to the fourth is greater than m, we can say that 1 is greater than m times x plus 3 to the fourth, right? Multiplying both sides by x plus 3 to the fourth. Right here, these cancel. We're just left with 1 is greater than m times x plus 3 to the fourth. We can divide by m to get that 1 over m is greater than x plus 3 to the fourth. And taking the fourth root of both sides, we can get that the fourth root of 1 is 1 over the fourth root of m is greater than fourth root of something to the fourth power is just something itself, x plus 3, and therefore x plus 3 is less than 1 over the fourth root of m. If we take the absolute value of this statement, right, then we can say that the absolute value of x plus 3 is less than 1 over the fourth root of m, right? This is because when you take the fourth root of something, you have to consider the fact that you can also take the roots of negative numbers, and therefore you have to consider the fact that, like if we were dealing with x squared, right, you have this value, which is, say, less than 1 over the fourth root of m, but you would also have this value, right? You have to consider the positive and negative, and therefore you have to take the absolute value of x plus 3 and only take values that are close to close to negative 3, but they can be on either side of it, right? So you have to take the absolute value. Therefore, if the absolute value of x plus 3 is less than delta, and the absolute value of x plus 3 is less than 1 over the fourth root of m, we can say that delta is equal to 1 over the fourth root of m. And therefore, since we have a relationship between m and delta that is true for any m, then we can say that the limit as x approaches negative 3 of 1 over x plus 3 to the fourth is equal to infinity.